Hi, so welcome to the new lecture for group theory. And before we start, I just want to tell you guys that my research now has my research work has escalated a lot, and because of that, it is going to be very difficult for me to upload videos daily. But yet, I am going to try. And to help me out, you guys have to please you guys have to motivate me, and that is by subscribing to my channel. Like my analytics tell me that most of my viewers are non-subscribers, so please subscribe to my channel. Okay, it really means a lot to me. So anyway, today we will be discussing about Millikan symbols. Okay, and before we discuss Millikan symbols, I'll take an example of a molecule and then discuss Millikan symbols. Okay, so I'll take an example of a molecule with D3H point group. Okay, so let's say we have PCl5. Okay, so you can imagine PCl5 as a triangle. Okay, wait, I'll just draw a triangle. So PCl5 we are discussing about. Okay, so this is PCl5. Okay, so these three chlorines, which are shown by triangular vertices, are in the plane. Okay, and in the plane of phosphorus, and these two chlorines are above the plane and below the plane. Okay, I'll just remove these chlorines just so that it does not interfere and it's very easy to comprehend. Okay, so you can just imagine it to be the vertices of a triangle. Okay, and so this chlorine is going inside the whiteboard, and this chlorine is coming outside the whiteboard. Okay, so now I've already given it. It's a D3H point group, but let's see how. Okay, so if you remember, like you have to see my previous lectures where I've discussed the point group of BF3. So if you see these chlorines and this phosphorus, it is existing in the form of BF3. Okay, it is like BF3. Okay, so now what we can do is, if we have to see the rotational axis. Which rotational axis does it have of highest symmetry? So if this is the z axis. Okay, and if you pass it through the phosphorus. Okay, so if you're passing it through the phosphorus, this chlorine, like I told you, is inside the whiteboard, this chlorine is outside the whiteboard. So when I'm taking this axis, it is passing through these two chlorines, this and the phosphorus, like this. Okay, so this chlorine is coming out like this. So I am taking an axis which is passing through this chlorine into the phosphorus and then into the whiteboard to the other chlorine, and then I rotate it by 120. So these chlorines will be exchanged and will get an equivalent configuration. So it has a C3 axis. Okay, and so it has got a C3 axis. Now let's see which all other axes does this molecule have. Okay, okay. Now if I what do I do is, if I pass an axis like this. Okay, if I pass an axis like this. Okay, through this chlorine and through this phosphorus in the plane of the whiteboard only, in the plane of the molecule. If I pass an axis like this and rotate it by 180. Okay, if I rotate it by 180, this chlorine is going to shift over this side. This chlorine will shift over here. And once I rotate by 180, this chlorine which is coming out of the plane will go below the plane, inside the plane, and this chlorine which is inside the plane, by rotating it by 180, will come outside the plane. Okay, so again we'll get an equivalent configuration. So it also has a C2 axis. And so if I am passing one axis through this way, this is the second C2 axis, and if I am passing through in this plane, then this is in this axis, this is the third C2 axis. So that's why it's three C2 axes. Okay, and what did I tell you? If we get something of the form Cn plus Nc2, if we get something of this form, then it is considered to be a D point group. So it has Cn plus Nc2, so it is considered as D. So C3 plus 3C2, right? So this will be considered as a D3. And like I told you, if this is our principal axis, that is the z axis, and if we cut the molecule like this in the molecular plane or in the plane of the whiteboard, then these three chlorines are getting cut in the molecular plane, so they will be reflected equally, and these two chlorines, they are at equal distance. This one is coming out of the plane and this one is going inside the plane. So if I have a plane like this in the xy axis, then this chlorine over here will be reflected inside the whiteboard, and the one inside the whiteboard will be reflected outside. So we will have a sigma H plane as well. So that's why I told you do not have to even see sigma V. If a sigma H plane is present, then you just write it as D3H. Okay. But in this molecule there is no sigma V plane. Now in the last lecture I hadn't told you about S3. What is S3? S basically. S is basically improper rotation. Okay. And let me check whether it's filming or not. Okay, it's filming. So yeah. So now talking about improper rotation, that is S. Now what is improper rotation? Improper rotation is nothing but, so basically this C3 is the proper rotation and this S3 over here is the improper rotation. Now what does this mean is, basically rotation followed by reflection is known as the improper rotation. So if we rotate a molecule and then reflect it in a plane which is perpendicular to the axis through which we have rotated. Okay. Basically what it means is that, for example, if this is the axis, okay, and if we rotate this molecule along this axis, okay, and then we reflect it in a plane perpendicular to the axis. So if this is our axis, so first we rotate the molecule, okay, by whatever angle we have given. So over here it's S3, so 120 degree. So basically what it means is reflect the molecule by rotate the molecule by 120 degree and then reflect it along a plane which is perpendicular to the axis. So the plane perpendicular to this Z axis will be the XY plane, that is the whiteboard. Okay. So if after rotation followed by reflection in the perpendicular plane we get the same molecule, then it also has an improper rotation. So let's see for this molecule. Now again we will take the principal axis, the Z axis, okay, rotate this molecule by 120, okay, rotate the molecule by 120, we get an equivalent configuration, and then reflect it along the XY plane. So if we reflect it along the XY plane, that is the whiteboard, and we have rotated by 120, we got an equivalent configuration, then we reflected it along the XY plane. So these chlorines are in the plane, so they will not be affected, and these chlorines which are outside the whiteboard and one inside the whiteboard, they will also be reflected. So we'll get an equivalent configuration if we have the improper rotation, that is S3. So that is why this molecule also has an improper rotation, and it is denoted by S3 because we are rotating it by 120 degree. So 360 by 3, or if you are rotating it by 120, so 360 by 120, this gives us 3. So that's why S3, similar to the proper rotation. Okay. But it's not always the case that the principal axis and the improper rotation will always be the same. There are some molecules where it has a C4 axis but it has a S2 improper rotation. Okay, so it's not necessary that the order of the principal axis will be equal to the order of the improper rotation. That is not necessary. Okay, so now I have explained you the point group. Now let's look at the Millikan symbols. Now what are Millikan symbols, okay, and what do we do with them? So first of all, this E is the identity, okay, and this so basically under identity it's given 1 1 2 1 1 2, okay, somewhere it will also be given 3. So first of all, A or B is the Millikan symbol which is used to depict only first order matrix. Okay, so the value under the identity, it's known as the character. So the character under identity, if it's 1, or if it's 1 means it's a first order matrix, then it is denoted by A or B. Okay, if it's for one order, if the character under identity is 1. If the character under identity is 2, it is denoted by E. Okay, and don't get confused between this E and this E. This E is the identity, whereas this E is the Millikan symbol. Okay, so if the character under identity is 2, then it is denoted by E. Okay, that is, it is a second order matrix. And if it's 3, then it's denoted by T. Okay, so somewhere in some other character tables you will also see E equal to 3. So there it will be depicted by T. Okay, so this is the very first thing that you need to remember. Now you must have seen that there is mentioned like A1 or it's mentioned like B1. Okay, A or B. Let's just talk about A and B. So now when to decide whether it's A or when to decide when it's B. So whichever is the principal axis of rotation. So the principal axis of rotation in our case is the C3 axis. So if it's symmetric with respect to the principal axis, then it's A. If it's anti-symmetric with respect to principal axis, then it's B. And what I mean by symmetric and anti-symmetric is basically if it's 1, that is it's symmetric. If it's -1, then it's anti-symmetric. Okay. So over here we can see that it's anti-symmetric. Okay, because it's -1. And this one over here, these ones are symmetric. So these will be denoted by A, and these anti-symmetric ones will be denoted by B. Okay. But again, like I told you, it has to be first order. A and B is only for first order. So here the symmetric anti-symmetric would not be valid, because here it's not first order, it's second order. So here it will be denoted by E. Okay. Okay, so we decided A and B. Okay, now when does A1 or A2 come? These 1 and 2, these subscripts 1 and 2, when do they come? So this is basically 1 and 2 is decided when, for example, after the principal axis we have a C2 axis which is perpendicular to the principal axis. Okay, a C2 axis which is perpendicular to the principal axis. If it's symmetric with respect to that, then it's A1. If it's anti-symmetric with respect to that, then it's A2. What I mean by that is, for example, in this case in PCl5, we had this phosphorus, these 3 chlorines, and we had a chlorine over here and a chlorine over here, right? Now what is happening is, I said something which is a C2 axis, not something, a C2 axis perpendicular to the principal axis. Now principal axis was in the Z plane, okay, in the Z axis, but our C2 axis was perpendicular to the principal axis. Principal axis was like this, and our C2 axis was like this. So it was perpendicular to the principal axis. So in cases where the C2 axis is present, in molecules where C2 axis is present, which is perpendicular to the principal axis, just remember that, which has to be perpendicular to the principal axis, and if it's symmetric with respect to that, we denote it by A1, and if it's anti-symmetric with respect to that, we denote it by A2. Okay, and if there is no other axis present, only the principal axis is present, for example here there is no C2 axis, then we go on to the sigma V. Sigma V means sigma vertical plane. So if there is only one axis present, there is no other C2 axis. For example, the molecule does not have a C2 axis, it only has one principal axis, then you directly go on to the sigma V plane. And if it's symmetric with respect to sigma V plane, then it's denoted by A1, and if it's anti-symmetric with respect to sigma V plane, then it's denoted by A2. Okay, so we got A1 and A2. Now you must have also seen A prime and A double prime, okay, or B prime and B double prime. Okay, that depends. Okay, so A prime and A double prime, when does that happen? So if the molecule has a sigma H plane, that is a sigma horizontal plane, and if it's symmetric with respect to sigma H plane, then it's denoted by A prime, and if it's anti-symmetric with respect to sigma H plane, then it's denoted by A double prime, or B prime and B double prime. Okay, and the one which this character, one more operation that this character table does not account for is in center of inversion. Okay, so here there is no center of inversion, but in some character tables you will also see center of inversion denoted by I. Okay, so if there is a center of inversion present, and if it's symmetric, that is the character under center of inversion say is 1. Okay, so then it's symmetric with respect to center of inversion, and then that molecule will be represented by Ag, where G is nothing but Girard. Okay, Girard is a German word, and it depicts the center of inversion. And if it's anti-symmetric with respect to center of inversion, that is the character under inversion is -1, then it's denoted by a U, that is Ungirard. Okay, so if it's symmetric with respect to center of inversion, then Girard, and if it's anti-symmetric with respect to center of inversion, then Ungirard. Okay, so now let's come on to the molecular symbols for the D3H point group. Okay, so let's come on to the D3H point group. So first of all, the matrix is 1. Okay, so that means it's either A or B. Then it's C3. The principal, it's symmetric with respect to the principal axis. That means it's A only. it's symmetric with respect to the C2 axis. That means it's A1. Okay, because I told you if 1 and 2 is decided with respect to the symmetry of the C2 axis, which is perpendicular to the principal axis. And the sigma h plane, that is equal to 1. So that means it's A1 prime. Okay, so now we can say that the first Millikan symbol is A1 prime. Got it? Now let's come on to the second. Again it's 1. Okay, it's symmetric with respect to the principal axis, so it will remain A. It's anti-symmetric with respect to the C2 axis, so that means A2. Okay, and if we see the sigma h plane is, it's symmetric with respect to sigma h plane, so it's A2 prime. Okay, now this is now second order. Okay, like I told you, the character and identity is second order, so this will be denoted by E. So here the C3 axis, antisymmetry with respect to C3 axis does not matter, it will remain E. Okay, that is only valid, A and B is only valid for first order matrix. This is a second order matrix, so this will not be accounted for in E. Then we come on to the C2 axis, no relevance again. Okay, there is no E1 and E2. Like in A there is A1, A2, there is in E there is no E1, E2. Okay. Okay. Then we come on to the sigma h plane. Now over here the sigma h plane is again symmetric. Okay, this is 2 because it is a second order matrix. Okay, don't get confused. So this is symmetric with respect to the sigma h plane, so that means it's E prime. Okay, okay. Now let's come on to the fourth one. So 1, again it's A, it's symmetric with respect to the principal axis. Okay, I might have made a mistake about the character table. Okay, I definitely have made a mistake in writing the values on the character table. Okay, just check the character table. Anyway, for convenience now I am taking it to be -1. Okay, just clarify. Just have a look at the periodic table and character table and clarify whether what are the symbols. I am just explaining you right now with whatever values I have. Okay, so I'll write minus just to make it a little okay. Anyway, so now we have 1 okay over here, and we see under the principal axis it's -1. That means it will become B, because I told you if it's symmetric or antisymmetric with respect to the principal axis, then it will be decided as A or B, and it's antisymmetric with respect to the principal axis, so this will be B. Okay, so this becomes B. Okay, so we write B over here. Now it's symmetric with respect to the C2 axis, so again B1. Okay, and it's antisymmetric with respect to sigma h, so it will be denoted by double prime. Okay. Okay, yeah, I remember now the character table. Okay, I'll just write it. I think I remember. Okay, so I think I missed out -1 over here. There was -1 over here. So if there's -1 over here, it becomes B1. Sorry. I have made some mistake. Sorry for confusing you guys. I'll just write it down like this. Whatever values I have, I'll go according to that. Okay, sorry for confusing. I didn't mean to. It just so happened. Okay, so again we'll just move on again. So okay, so it's antisymmetric with respect to C3 principal axis, so B, it will become B. It's symmetric with respect to the C2 axis, so B1, and it's antisymmetric with respect to sigma h. So if it's antisymmetric, what did I tell you? It will become double prime. Okay, then we have again we'll have B over here, because it's antisymmetric with respect to the principal axis, and it's antisymmetric with respect to the C2 axis also, so it will become B2. Okay, and the sigma h plane is -1, so the sigma, it's antisymmetric with respect to the sigma h plane also, so it will become B2 double prime. Okay, that's it. And for E again over here it will become E. There the principal axis, the antisymmetry or symmetry with respect to the principal axis or the C2 axis does not matter, but we have to see the sigma h plane. Over here the sigma h plane is minus, that is antisymmetric, so it will become E double prime. Okay, so these are the Millikan symbols, and these are the ways to find out. For example, in this particular case only, we had a inversion also, I. Okay, and we had say 1 1 1 1 1 minus 1. Okay, so over here, since these all are symmetrical with respect to the principal axis, so we can write it as a1g, a2g double prime, okay, b1g, b2g. But over here, it's anti-symmetrical with respect to the principal axis. Here also we write g, okay, and it's anti-symmetrical with respect to the principal axis, so it will become e mu, mu or Ungerard. Okay, so these all will become g, and this will become u, because it's anti-symmetrical with respect to the principal axis. So I would suggest you guys to go for the different character tables that are present. Okay, do not look at the Millikan symbols and try and figure out the Millikan symbols by yourself by whatever criteria I had just mentioned a few minutes back. And what else you can do is go for simpler character tables first. Okay, like C2V, C3V. Gain some confidence and then go for the higher character tables. Okay, and in the next lecture I will be talking about rotational and Raman active modes. Okay, so this was the basic character table. After this I will be talking about Raman active and IR active and rotational active, how to calculate these modes of vibration with the help of the character table. Okay, and I will suggest you guys to, once you are thorough with group theory, first of all go for Hui, okay, inorganic chemistry by Hui. Like I have been doing a lot of questions from the question papers from CSI Net, and whenever I open Hui, whenever I get time, I open the book, there has to be 3 or 4 questions that are coming from Hui as it is. Like there is no change at all in the questions. Okay, so they just pick the questions and drop it in the paper. That's how they are doing it. Okay, and everything is coming from Hui. Even if you look at the NPTEL modules that that are present on the website, and if you go down, okay, scroll down to the last page and see the references. The first reference of any inorganic topic is Hui. Okay, so all the IIT professors, all the NPTEL professors, everybody has Hui, and whenever they are forming questions, they do not have the time to frame a question, so they always pick from their favorite books. So Hui is like one of the favorite books of all teachers, at least in India. So just buy Hui, and but Hui is very concise. Okay, so you have to learn a topic from some other book, and when you are thorough with that topic, then you come on to Hui and try and understand, try and do the questions, try and understand their language. Okay, the language is a little tough. So, but it's very important for you to read books from foreign authors. Okay, Indian authors are good, no doubt. Okay, but there is a particular way, there's scientific language that you need to know in order to do well in interviews. Okay, so just cracking CSI Net is not good enough. If you want to go to good institutes, you need to have a good scientific, strong background, a strong knowledge. Okay, and you need to be thorough with scientific terms. Okay, you cannot go there and say G and U and stuff like that. You have to be very specific. Like these small things matter. You have to be Gerard, Ungerard. You cannot say because it's negative, hence it will be Ungerard. Okay, you have to say anti-symmetric, symmetric. So these are very small things that matter a lot. So just concentrate on these things. Okay, and that is why I always recommend to read foreign authors. So if you want to get your concepts right, you're not able to understand their language, go for Indian authors. But after that, do give foreign authors a good read. Okay.